Hello everybody, how you doing today? This is a follow-up on the video I did, Router on a Stick Part 1. Actually, in Router on a Stick Part 1, we didn't do any router on a stick. We just took a switch, created two VLANs, took a router that had two Ethernet interfaces, stuck one in each VLAN, and demonstrated that we could route between the two. The problem that we run into in this scenario in a lot of cases is, what if we have three VLANs? Well, now we need a router that has three physical Ethernet interfaces. What if we have four? Well, now we have a need for a router with four interfaces. The other problem is that switch that starts out at 24 ports, when we need two, since the router's having to plug into two different VLANs, now we're down to 22 ports. 3, we're down to 21. 4, we're down to 20. Not long before, all we're doing is using switch ports to plug in router interfaces and have no place to plug in individual users. And that's where the idea of router on a stick really gets important. So what I'm going to do in this part 2 is I'm actually going to demonstrate that. And what router on a stick is actually doing is we're going to create virtual interfaces on the router. So we have multiple theoretical or software virtual interfaces on the router trunked to a switch, eliminating the need for having a connection per VLAN. So let's start off by going to Packet Tracer, and we'll do a quick review of what we did before. This time, just to show you, instead of doing two VLANs, I'm going to do three. So what I'm going to do is I'm going to start off by getting me a switch. I will use the 2950-24. Do a little quick configuration on this guy. Come in here and yes, I know. Display name for him. Switch with three VLANs. That sounds good. Host name on the switch, we'll do an enable conft host LAN switch VLANs. How about that? That looks pretty good. We'll say enable secret. We'll make the enable secret please. We'll do service password encryption. LineCon 0 will be please. Oops, my bad. LineCon 0 will be password please. Getting too big of a hurry there. We'll ask for it at login. Line VTY will be 015 for my telnets. Now it's interesting. Somebody said to me, you know, I know I put this in right. I know I said line VTY 015, but then it came back and said line VTY 04, line VTY 5 through 15. You can't keep it from doing that. That is actually the default behavior. So don't be upset about that. You didn't do anything wrong. It just wasn't what that wanted to display at the time. Okay. Well, you see now I've gone in, I've named my switch, I've given it passwords, I've set up my telnet, all this neat stuff on there. So if we do show VLAN, you can see I now have 24 ports, and they are assigned all to the default VLAN, which is VLAN 1. So now we can fix that, and what we're going to do is we will go in and look at our range. We'll say conft. I got a piece of paper sitting here on my desk making myself some notes. I'm going to use VLANs 3, 5, and 7, and I'll do 5 through 10 as my ports on 3, 15 through 20 on 5, and 23 and 24 on 7. That should work pretty good. So what we'll do now is we'll do, we want to do an interface range statement. So when we get ready to do that, we'll do interface range, and I'm going to go 5 through 10. Got to get my little dash in there. Okay, and I'll do switch port access VLAN 3. And then we will go up there and we'll look at ports 15 through 20. and we'll make that VLAN 5. And if you see me, all this coming up here real fast, all I'm doing is using my up arrow keys and using my history function, since I'm not terribly worried about how this is going to play out. I just know that I need to change certain things. So now I can come in and do show VLAN, and you see that I have the ports that weren't tampered with, 1, 2, 3, 4, 11, 12, 13, 14, 21, 22 are still in VLAN 1, which is the default, but 5 through 10 is now in 3, 15 through 20 is now in VLAN 5, and 23 and 24 are now in VLAN 7. So if I went in and put a user, and I will do that, let's get some generic devices. If I put a user in each one of these VLANs, now I have the problem that I have before. If I come over here and I look on this guy right here and I give him an address, let's see, we will make him static, we'll make him 10.0.0.2 subnet mask and 10.0.0.1. So now we have that. I can check it out by doing ipconfig. And you see I do have that. I'll come over here to this next one. We'll say he's 172.16.0.2. His default gateway is 172.16.0.1. And we'll check him out. Okay. And then we'll come over here to this guy. Now, if you're saying, where are you getting those addresses from? Well, I'm using the private address space. 192.168.3 is the space in Class C. 172.16 being B, and 10 being A. So that's all I'm doing. If you want to guarantee that the VLANs are in place and that they do stop this traffic without a router being involved, I can attempt to ping 10.0.0.2. And we'll give it a second just to prove that it can't get there, but I think you'll find that it truly can't get there, that it's going to time out all the way across. And what I need to do now is I need to get me a router out there. And I'm going to bring a 2620 router out, and you're going, but wait a minute. You brought out a 2620. It's only got one Ethernet. You're right, it only does have one Ethernet, but I'm going to do something different on this one. What I'm going to do is I'm going to go in and I'm going to create sub-interfaces or virtual interfaces on that fast Ethernet. So we'll come in, we'll do enable, conft, we'll name this one router on a stick, since this is actually our router on a stick. Enable secret to be please. We'll do service password encryption. Passwords please there. So now we have all that in there. Now the thing that we need to come back here and look at is, first, let's go to interface F00. Okay? Now, when we're looking at interface F00, we don't want to put an IP address on F00 because it's the overall physical interface. So all I'm going to do is I'm going to type no shut. And if you look, you'll see, and I need to come over here and put me a connection to port 1. But if you come over here and look, you will notice, and I can change this to router on a stick where it looks better up here too. Now it actually looks the way we want it to look when it's on the screen. If you look at this, and I do show IP interface brief, from where I did that no shutdown, you can see that my protocol is actually up and up. But what I need to do now is I need to do conf t interface. Now what I'm going to do is, since I'm wanting to be able to route the traffic that's on VLAN 3, I'm going to say interface f0/0.3. And if you look, it didn't go to config-if, it went to config-sub-if. Because what I'm saying when I say fast Ethernet 00.3 is that I want to create a sub-interface. The .3 is a sub-interface, and the reason I picked 3 is because I'm going to use that as a sub-interface to route back and forth between VLAN 3. Well, if you look at your options here, you see I can tamper with ARP, bandwidth, delay, description, encapsulation. Well, the first thing we need to do here is we need to deal with encapsulation. So I'm going to say encap, and look at what I've got. I've got .1q, and then it needs to know the VLAN ID. So I'm going to say .1q VLAN 3. It doesn't like that. Okay. So what I've done is I've created, and you can see, you saw how I went through the question marks. It gives me the little caret at the VLAN. It didn't like that. It didn't want me to say that. It just wants me to say, make the encapsulation .1q or 802.1q and associate it with VLAN number 3. And it did it. So now I can put the IP address up there. And I'm going to say 10.0.1, which, if you remember, this is the default gateway. Now, let me show you something interesting. If I come back here and do show IP interface brief, did I have to no shut that sub interface? Absolutely not. The no shut actually comes on the physical interface, which was F00. Since F00 is up, the F0/0.3 is up as well. So let's go do that again, just to do it by way of review. We'll do interface F00, and this time I'm going to do sub interface 5. Okay. Encap .1q VLAN 5. Now, some of you will try these commands in different orders. I think you will find out that you're not going to be able to put an IP address on a sub interface until you change the encapsulation. That's going to give you a little bit of a hard time. Since this one was the one that I associated with the class B private space, that will be that one. And I also can do F00.7 encap .1q7 IP address 192.168.3.1. And hit a Control Z just to go back to the prompt, and I can do show IP interface brief. And you'll notice now that I have my major interface up, but I also have all those virtual interfaces. I also can look at my routing table, do a show IP route, and you can see that they are listed as physically connected interfaces. Okay, so what if now I come over here and come to the command prompt? You can see this guy is 10.0.0.2. Can he get to his gateway? Well, that 10.0.0.1 will be on the sub interface. What's the problem? Where do we have a problem now? Well, let's look at the switch. If we look at VLAN assignment, port 1 is still listed as an access port. It's still in 1. If it's going to actually trunk information between this router, what do I need to have happen to that port? Well, let's take a look. I can do conft interface F01. See, what are my options? Let's see. I could manipulate CDP, channel group, duplex, MAC, spanning tree. Switch port sets the mode. So that's kind of what we're looking for. Switch port. What do we got? We got switch port priority, switch port trunk, or switch port voice. Well, we kind of want this to trunk. So what do we got? What if we just say switch port trunk? Incomplete command. What if we just say switch port allowed? Switch access VLAN and a number. Well, now we're seeing switch port trunk. Well, what VLANs are we allowed to put down there? And I'm saying all. So let's go back and look at show VLAN again and see if a change was made. Maybe, maybe not. Can we get across this now? Let's see. If we come back up here to the command prompt, we do an IP config. We are still 10.0.02, and our gateway is 10.0.0.1. So let's see if we can ping 10.0.0.1. Okay, if we do have those up and we're trying to get across those, what could be our potential problem here? Well, let's look at this one. Switch port mode, trunk. We need to actually tell it to do the trunking. The thing that I forgot to tell you is you have two right there. You have a command you need to do switch port mode trunk to change this from access to trunk, and then you need to do switch port trunk to tell it what are allowed to go across there. So when we do just one and say let this go across there, it doesn't really change anything, because if you noticed when we did show VLAN before, when we did show VLAN before, we still had number 1 left assigned to VLAN 1. Now that we've actually made it a trunk port, we don't have this. So that's the main thing that you have to do right there, is you have to remember to not only allow the VLANs to pass, but you also have to manually change that to trunk or trunk capable. If I come back over here now, if you notice, I can not only ping that one, but now I can ping the other VLANs as well. Main thing, don't be afraid to play with this. Make sure you remember all these, and I'll go back and do it one more time. Make sure that you remember one if you want to do, let's say, interface F01. If you want to control the mode, this is where you can go in and sorry. This is where you can actually go in and choose that you want to be trunk. Now, in this case where you have dynamic, would it negotiate to trunk? It would, because the router is set up for .1Q, which is a trunking protocol. So it would dynamically get there, but it's also easier if you know it's going to be a trunk line, just go ahead and set it. The other thing you could do is switch port trunk, and actually look at what VLANs are allowed along there. Have fun playing with this. Make sure you can get these up and running. It's a good example of router on a stick. Have a good one, guys.